Normal stiffness is a numerical concept for all penalty-based contacts like pure penalty contacts or augmented Lagrangian contacts. Here, we allow for penetration between contact and target, with the contact stiffness being the penalty for penetration. In reality, there is infinite stiffness between the contact and the target, or there is no penetration between the contact and the target bodies at all. When you specify a normal load F to a contact body, you will obtain the same force as the contact reaction, irrespective of the normal stiffness defined between them. However, as you see, the penetration between the contact and the target would be low for high contact stiffness, and the penetration would be high for a low contact stiffness. Please note, the spring that you see is only for visualization purpose and do not contribute in the physics of the problem. You can alter the normal contact stiffness either by specifying the normal stiffness value here or by specifying the penetration tolerance here. When you specify the penetration tolerance, the normal stiffness is computed based on how much you are going to allow the contact to penetrate the target. More the penetration you allow, less would be the computed normal stiffness, and less the penetration, more would be the computed normal stiffness. The point to note here is, if you specify a normal stiffness to be constant at all times, to be a specific value, for example, like this, you can no more change the penetration tolerance, as the penetration for a given normal stiffness is always fixed. You can observe that the option to change the penetration tolerance no more exists here. Hence, penetration and normal stiffness are interdependent. When you specify high contact stiffness, the penetration between the contacting bodies are going to be very less. However, this might lead to difficulty in convergence. Hence, when you have a high stiffness, we move close to reality with difficulty to solve them numerically. And when you specify a low contact stiffness, the penetration between the contacting bodies are going to be very high. However, the numerical convergence is going to be achieved faster. Hence, when we have a low stiffness, we move away from reality. However, we solve them easily. Hence, we need to choose the optimal normal stiffness as a trade-off between numerics and reality. Ansys helps you to choose the contact stiffness automatically for you, and in most cases, they are good enough.